Week 3, we have a test next week. Is that date on your calendar? I hope so. I hope you've set a reminder for yourselves. Also, you have quizzes that are due, and remember that there are requirements to write the tests. If you're doing this course online, all of the video lessons need to be watched. And whether or not we're doing this online, you have to have completed the required quizzes. If you're not sure what those are, please check your course outline. And if you're doing this course in person or online, you have to attend the Tuesday Zoom classes. In person, you need to be attending the required classes. If you're not meeting those requirements, you won't be permitted to write the test. Please refer to your course outline if you're not sure what the requirements are for each test. So we just finished a pretty difficult section of graphing piecewise defined functions. I hope you've spent enough time practicing those so you feel comfortable with them. I also hope that you memorize those basic function graphs. I gave you that set of pages for practice and review, and the solutions to those should be posted on the class Moodle page. If they're not, please let me know. Because now we want to use those basic function graphs to look at transformations, to look at changing not the shape of the graph, but perhaps shifting them left or right, up or down, maybe stretching them longer and thinner, or compressing them shorter and wider. We want to make changes to those basic function graphs. So what kind of transformations again? We said they can be horizontal or vertical shifts. So we're maybe moving them left and right, maybe moving them up and down. We can stretch or compress a graph horizontally or vertically. A transformation might also be a reflection. We can reflect a graph across the x-axis or the y-axis or both. And these transformations can be applied to all function graphs. So for now, we're going to look at those 8 basic graphs that we talked about at the beginning of week 2. But as we move forward this semester, we're going to apply those transformations to exponential functions, to logarithmic functions, and to trigonometric functions. So you can't forget these function transformations. You need to know them and be ready to apply them in any situation. So we're going to start with a reflection. And notice that we've put a negative outside of the function. Notice that it says y equals the negative f of x. That tells me that I'm applying that negative sign to y. We've memorized basic points on the graph, basic x, y points. We're going to take those points, we're going to keep x the same, and we're going to find the negative of y. So in each of these cases here, I've drawn the basic function graph. This is the f of x. Now we want to draw the negative f of x. So if this is our positive c here, then we can see that negative c is a reflection across the x-axis. It's the same graph, we've simply reflected it. Now let's think about those key points. Our original key points were -1, positive c. Now we've got -1, negative c. We had a point at 0, c. Now we have a point at 0, negative c. We had a point at 1, c. Now we have a point at 1, negative c. We've put a negative on all of the x values. In the linear function, I've drawn the graph here for the f of x. You know those 3 key points. What are the new key points going to be? Instead of -1, -1, It's the opposite of 1. 0, 0 stays the same. Instead of 1, 1, it's the opposite of that 1. So my new graph, negative 1, 1, 0, 0, 1, negative 1, is again a reflection across the x-axis. This part was below the axis, now it's above. This part was above the axis, now it's below. Let's look at the quadratic function. I've graphed the f of x. We want to look at the negative f of x. So think about the key points on this graph. What will the new key points be? We made each of the y values negative. So now we have negative 1, negative 1, 0, 0 stays the same, and 1, negative 1. Notice that again, we have a reflection across the x-axis. This was above, now it's below. This was above, and now it's below. I guess I could have drawn that a bit better because I know at negative 2, it's going to be at negative 4. There we go. That looks better. Don't worry about your graphs being exact. Mostly I'm looking for close enough when I ask you to draw it for me. What about our square root function? So again, we're looking for the negative of f of x. I've drawn the f of x here. We have our key points. This time we didn't use negative 1. We can't let x be negative. Do you remember the key points? Write down the new key points. Again, you made each of the y values negative. You reflected it across the x-axis. And there we have the negative f of x. Do the same thing. Find the negative f of x for the cube function and the cube root function. I hope you had these new key points. I hope your graphs were these reflections across the x-axis. And I just want to note that I've put an arrow on, and you should as well. These graphs continue to positive infinity and negative infinity. So two more functions, our absolute value function and our rational function. Again, we're finding the negative f of x. We're finding the opposite of our y values. Remember that for the rational function, we're only looking at 2 key points. Find these transformations. So again, you have your new key points. The x stays the same, the opposite of y. It is a reflection across the x-axis and a reflection here as well. And I hope you remembered to label your horizontal and vertical asymptotes. I will always be looking for that on any function graph that has an asymptote. So it's good to get into the habit of putting those in.